now we're going to look at part 2 of the axial skeleton. We've already looked at the skull, so now we're going to look at the vertebral column, the ribs and the sternum. And the first region of the vertebral column just here is called the cervical region. And usually in something like an alligator, we've got 9 cervical vertebrae. We've got a well-developed neck, lots of independent head movement. First vertebra is going to be the atlas, which articulates with the skull, and the second one is the axis, which obviously makes a joint with the atlas and allows quite a lot of head movement compared to amphibians. If we move on to the next region, we are looking at the thoracic vertebra, and there are usually 10 thoracic vertebrae. We'll find ribs attached on them, and 8 of the ribs, when we look at them, will run down and they'll join on to, it's a little bit difficult to see underneath here, but they'll be attached onto the sternum down below. And then the last 2 pairs of ribs just here are going to be free. They don't actually attach onto the sternum. Following that, we've got 5 well-developed lumbar vertebrae. And you'll see when you look at the lumbar vertebra, that's where your big, powerful back muscles are going to attach. We've got lots of large processes, such as transverse processes. And then if we move along to the next region, we've got 2 sacral vertebrae, and this is the region that the pelvic girdle is well and truly attached to. It's quite different from the pectoral girdle, which is only sort of slung there in muscles, but the pelvic girdle is firmly attached onto the sacral vertebra. And then following that, we can have as many as 60 caudal vertebrae, which are obviously tail vertebrae. The other somewhat unusual thing about the alligator is posterior to the sternum. So the sternum's down in there, but they're not really showing up very well on this particular sample because I think many of them have kind of fallen off. But in this region just here, what we'll often find on the alligator skeleton are what look like ribs. They're dermal bones, but they don't actually articulate here with the vertebra, and these are called the gastralia. And they're not for breathing, but they're the site for the ventral muscle attachment, and they provide lots of support for the abdomen. Obviously, when we're looking in this region, just here, thoracic region, the ribs and the sternum are very much used for breathing. And what you'd find in a typical crocodile is you'd find muscles between the ribs, you'd find a diaphragm back here, and they're going to breathe in a very similar way to how we breathe. They would contract the diaphragm and move it down. They would contract the muscles between the ribs, moving the ribs up and out. The only other feature of them is on this side of the diaphragm, on the lung side, they've got a large liver. So when the diaphragm pulls down, it pulls the liver out of the way. This enlarges this whole thoracic cavity, and the lungs are able to expand and air gets sucked in. Now, very, very recently, the latest research has shown that these lungs that you find on alligators and crocodiles are incredibly efficient. They are, in fact, as efficient as bird lungs. And although they don't have air sacs in their bones or throughout their body, what they do have is where the trachea branches into the bronchi, and then as the bronchial tubes go into the lungs, they divide into 2, and one of those branches brings air into the lungs in one direction, and the other branch takes air out of the lungs in the other direction. So there's no mixing, which makes it very, very efficient. And it may be that perhaps a common ancestor, an archosaur ancestor of crocodiles, birds, and dinosaurs, developed such a way of breathing, and then you can see from there how it transformed into the kind of efficient breathing system we find in birds.